this video, you're gonna learn about arrays in 10 minutes, and stick to the end of the video because I'm gonna be walking through a Leetcode problem that involves a fundamental algorithm. With that being said, let's get into it. All right, I'm gonna jump straight into the definition of arrays. And what an array is that, think of it as a container that stores multiple elements, and we can represent them in Python using square brackets. So what that's gonna look like is I'm gonna say, we can have an array called nums is equal to, and we say square brackets 1, 2, 3. And the main thing that we care about in an array is the index, which Python uses zero-based indexing. And we also care about the value that index refers to. And in an array, the values are stored in contiguous locations, meaning that we can directly access a value using its index. So if I want to get the second element in the array, I can just say nums, and then inside square brackets, I pass in the index number. And that's gonna give me 2 over here. And contiguous, because these values are stored in contiguous memory locations, that means that they're stored right next to each other in memory. Okay, so there's two main types of arrays. There's the static array and dynamic. And static arrays basically have a fixed size, and you can only have one certain type, one data type in the array. So for example, we can only have an array of integers, only have an array of booleans, and can only have an array of strings. You get the idea. And we can't add or remove values from the static array because it has to remain the same size. Dynamic, on the other hand, we can have any kind of data type inside the array. So we can have integers, we can have floats, we can have strings, we could have booleans, and we can also add or remove values, and it's a lot more flexible to work with dynamic arrays. The good thing about Python is that when we create an array, and it's actually called a list in Python, not an array, but when we create a list, it's basically implementing a dynamic array. In other languages, we have to worry about declaring as static or declaring as dynamic, but Python's nice because we don't have to do any of that. And so from now on in this video, I'm going to refer to arrays as lists because this video is used in Python. So now I'm going to talk about the time complexity of lists. And there's many different types of operations. When you're adding a value to the end of a list, which is called append, that's going to be O of 1 time. And it's O of 1 time because let's say we have a list 1, 2, 3, and we want to add 4 to the end of the list. Well, that's not going to require any of these elements to shift anywhere. We don't need to shift them anywhere because we're just adding a value to the end. And so it's going to be 1, 2, 3, 4, and the previous values are going to remain at the same place. So that's why it's O of 1. And if we want to pop a value from the end of the list, that's going to be also O of 1 because if we want to remove this, these values won't be, the position of these values won't be changed. It's just going to be 1, 2, and we can, if we wanted to call the first element by saying the list of 0, we would still be able to access the same value, 1, even after we removed the 3. And on the other hand, if we wanted to remove or add values in the middle or beginning, that's going to be O of n time because Because let's say I have 1, 2, 3, 4, 5, and I want to remove 3. Then the 4 and the 5, these positions are going to change now because now it's going to be 1, 2, 4, 5. So before we move to 3, we're going to say list of 0, 1, 2. It's going to be 3, third index, to access the 4. But after we remove the 3, it's now going to be list of the second index. So this means that the position changed, and the worst case scenario we remove from the beginning, and all the other elements have to shift to the left. And the same goes for adding a value in the middle. So if I have 1, 2, 3, 4, 5, and then I want to add a value here, let's say some random number 6, then it's going to be 1, 2, 3, 6, 4, 5, and these values over here, they're going to be shifted to the right. So the position is going to change. That's why it's O of n time. And if you don't know what O of 1 or O of n time means, then it's important that you check my other video out where I made a video on big O notation, because that's a fundamental topic you have to understand before learning about arrays. Now I'm going to talk about one of the most fundamental algorithms with arrays, and that's called binary search. I'm going to give a quick overview on it because we're running low on time here. So I'm going to say, or basically what binary search is that it's where we have a sorted array, and this algorithm only works with sorted arrays. So let's say we have 1, 2, I'll come with different numbers, 1, 5, 9, 12, 15, and it has to be from in a sorted array or sorted list. And the idea is that we have the left pointer starting at the beginning of the list, a right pointer starting in the end of the list, and the middle starting at the middle of the list. And to get the middle pointer, or to get the middle value, we have to take the index of the left pointer, which is 0, the index of the right pointer, which in this case is 0, 1, 2, 3, 4. We do 0 plus 4, 0 plus 4, and then we do integer division of 2 divided by 2, and that's going to give us 2. And so this is why the middle is going to point over here. So basically what these pointers are is they're basically the indexes of the list that are pointed to a value, the corresponding value in the list. And we have to do a loop, and usually we say while the left is less than or equal to right. Sometimes it could be left is less than right. It depends on the case. But the idea is that whenever we have a value that's, let's say our target value, let's say we're looking for 12, because the whole idea of binary search is finding a target value within the sorted array and finding where it is. If our middle value is less than the target value, so in this case 9 is less than 12, that means that we're going to shift this left pointer to the middle index plus 1, because we don't want to consider any of the cases to the left of the middle the value, because we know that the values to the left of middle have to be less than it, since it's a sorted array or sorted list. So now we're going to shrink our range of values so that the left pointer is pointing to here, not to the 12, and our middle is now going to point to this value over here. And so we're going to keep on doing this until our middle value is equal to our target value. In this case, our middle pointer is pointing to 12, so we end a loop there. And now I'm going to show you a complex Leetcode problem that will basically implement this idea. It says, given an array of integers sorted in ascending order and an integer target, we want to write a function to search target in nums. If it exists, then we return the index. If not, we return -1. And so, like I said before, over here, we have a left pointer at the start of the list and a right pointer at the end of the list. So what I want to do is I want to set 2 pointers, set left and right. And I'll set left equal to 0, and then right equal to the length of nums -1, because we want to, because length of nums -1 is going to get the last element of nums. So now I'm going to say while left is less than or equal to right, and it's really important to get this equal part. And you have to know it depends on the context of the situation of what problem you're doing. But in this case, we do say it's less than or equal to, because if our target value might be the last value in nums, and in that case, we're gonna get a situation where left is equal to right. But we still want to check that case. We don't want to break out of that loop. So I'm gonna say while left is less than or equal to right, I'm gonna say mid is equal to, and like I said before, it's the left plus right integer division of 2. And then we're going to check each case. And so I said before, if the left pointer, or the value of the left pointer, so the left value is less than the target, that means that, so like we said over here, if if the middle value is less than the target, so where were we at before? It was over here. So this was the middle, and our middle is less than our target. So in that case, we want to shift this left pointer to middle plus 1. So it's going to be left is equal to mid plus 1. And then elif nums of the middle is greater than target, meaning that, so let's say our target was 5 here. Then this would mean that our middle is greater than the target. So we would shift the right pointer to mid -1 because we want to shrink it this way. So it's going to be right mid equals to mid -1, and then else, this means that the middle value is equal to the target, and then we're going to return the middle because we want to return the index of where the target value occurs, and mid represents the index of nums, not the actual value. And if we're out of the for or the while loop, that means we never got a case where we found the target. So we're going to return -1. And I'm going to run that. Hopefully we don't get an error. And we didn't. And I'm going to submit it. And this is going to be O log n because we're shrinking the range of values each step. And it's going to be O of 1 space because I'm not creating any additional data structures. So I hope this helped. This is a really foundational idea that you have to know in DSA. And let me know if you have any questions in the comments below. If you haven't already, make sure to check out this video over here, which goes over big O notation. And it's really important that you understand big O notation before learning data structures and algorithms. Other than that, thank you guys so much for watching, and I hope you guys have a great rest of your day.